Right. Now you see this question now. Particle having charge q and mass m is dropped from a large height from the ground. Right. There exists a uniform horizontal magnetic field in the entire space as shown in the figure. Assume that the acceleration due to gravity remains constant over the time over the entire height involved. This case is the same as you can see here. You can see here. This is the direction of E. In the place of mg, you take QE. Right. In the place of mg, you try to take this thing. Right. Next. Now what happens? Now you need to identify the direction of E bar cross V bar, all that. Remember, this is what I am trying to explain you. In our standard question, which I will show here, so that there is no confusion. And the notes right. See, in our standard question, you need to notice two things. One, direction of E cap. Two, direction of E bar cross B bar. This is E bar cross B bar. E bar is I cap direction. B bar is, in this case, what is the direction of B bar? Outward ante కాదు కాదు మీరు K cap cross I cap అంటే you are facing J cap direction. What is I cap cross J cap? K cap. సో ఇంక నుంచి స్టాండర్డ్ గా గుర్తుపెట్టుకోవాల్సింది ఏంటంటే, ఇఫ్ దిస్ ఈస్ E bar direction, remember, if this is E bar direction, identify another axis perpendicular to this, which is E bar cross B bar. I am repeating again, please follow carefully. If this is E bar direction, identify E bar cross B bar direction. First step. Second step, the cycloid will be in the plane containing E bar axis and E bar cross B bar axis. And third thing, the curvature is like this, such that this extent is along x-axis and the length spread is along E bar cross B bar direction. So all your coordinates, whatever that I have defined here, all your coordinates, you see, this is the fundamental diagram that you should by heart. You should by heart copy. So this you should by heart all the time. Wherever it is required, just simply by heart. Later, you cannot derive all. If you, in entire magnetics, this is the difficult part. I have derived this yesterday. So therefore, if this is E bar direction, if this is E bar cross B bar direction, then this is how you will have cycloid path. In this cycloid path, this is x coordinate, E by B 1 minus cos omega t. This is z coordinate, E by B. అసలు ఇది గుర్తుపెట్టుకోవద్దన్న నేను వెలాసిటీ టర్మ్స్ గుర్తుపెట్టుకోమన్నా నేను మిమ్మల్ని. If this is x coordinate, E by B sin omega t. If this is z direction, it is E by B 1 minus cos omega. What is z direction? Z direction ఉండదు. Along E cap direction, E by B sin omega t. along E bar cross B bar direction, E by B 1 minus cos omega t. ఇప్పుడు ఈ క్వశ్చన్లోకి రండి. మన క్వశ్చన్ ప్రకారం ఇప్పుడు నాకు అర్థమైన దాన్ని బట్టి ఇది ఈ బార్ అంటే ఈ బార్ క్రాస్ బి బార్ కావాలి. సార్ మమ్మల్ని మోసం చేస్తున్నారు. ఓకే, నో ఇష్యూస్. ఇదొక యాక్సెస్, ఇదొక యాక్సెస్ అని అనుకోండి. ఇది ఈ అయింది. ఇప్పుడు అదేలా ఎంజీ ఈ బార్ సేమ్ ఇన్ ద ప్లేస్ ఆఫ్ ఎంజీ, ఇన్ ద ప్లేస్ ఆఫ్ క్యూఈ ఎంజీ 1 force యూనిఫార్. నెక్స్ట్ ఇప్పుడు ఈ బార్ ఐడెంటిఫై చేశారు, అది ఇన్వర్ట్సా? రైట్. ఇప్పుడు ఈ బార్ ఐడెంటిఫై చేశారు, అది ఇన్వర్ట్స్ ఉంది. ఇప్పుడు మీరు చెప్పండి, ఇదే కదా ఈ బార్ క్యాప్ బి బార్ డైరెక్షన్. ఇప్పుడు సైక్లాయిడ్ ఎటు వెళ్తుంది? ఇదే కదా సైక్లాయిడ్. అయిపోయింది. ఇప్పుడు ఈ డైరెక్షన్లో వెలాసిటీయే మనం ఏమని చెప్పాము? ఈ ఎలాంగ్ ఈ బార్ డైరెక్షన్ E by B sin omega t. Along this direction E by B times 1 minus cos omega t. ఓకే, ఓకేనా? ఇప్పుడు ఇక్కడ మ్యాక్సిమం వెలాసిటీ ఎంత అవుతుంది? 2E by B అవుతుంది. అలానే ఇప్పుడు ఈ డైరెక్షన్లో, ఇది ఈ డైరెక్షన్లో ఈ క్యాప్ డైరెక్షన్లో కోఆర్డినేట్ ఏమవుతుంది? సో ఆ కోఆర్డినేట్ వచ్చేసి ఈ క్యాప్ డైరెక్షన్లో కోఆర్డినేట్ ఈ బై బి ఒమేగా ఇంటూ ఎలాంగ్ ఈ డైరెక్షన్లో 1 మైనస్ దీని కాస్ ఒమేగా టీ. అంతేగా? దీని మ్యాక్సిమం వాల్యూ ఎంత అవుతుంది? దీని మ్యాక్సిమం వాల్యూ 2E by B ఒమేగా. మీరు గుర్తుపెట్టుకోవాల్సింది ఈ మూడే. ఐఎమ్ రిపీటింగ్ అగైన్. Identify first E bar direction. Next, identify E bar cross B cap direction. Your cycloid path will be like this, as if like some toranum is fixed to this axis. Garland, otherwise. Now the question is, in this direction, E cap direction, the velocity component is E by B sin omega t. Along E cap cross B cap, E by B 1 minus cos omega t. The maximum distance is 2E by B omega. And the direction, maximum velocity is in this direction, that will be 2E by B, 2E by B omega. 2E by B is the velocity. If you know this, you can play anything like with this arrangement. Any doubt? Right. So now this is the picture what we have. Okay. Now you apply simply the conditions required. Find the speed of the particle at the moment its velocity becomes horizontal. Velocity becomes horizontal, it is 2E by B. But the problem is there is no E here. There is no E here. So in the place of E, I will write mg by q. So 2mg by bq. Okay. One simple step. Got the point? Pakka? Right. So therefore, this is what we have. Next. Right. So this is a very fundamental model. I am going to discuss a very difficult questions today, but before that, some models we will work, and some theory also we will work. Some theory, some more theory we will work. My point is very clear. I want to finish it. Right. Take illustration 1.20. Read this. Can you see that clearly on the board? సంజన నిద్ర వస్తుంది మళ్ళీ. A non-relativistic charge Q of mass m originates at point A lying on the x-axis and moves with velocity v at an angle alpha to the x-axis. Screen is located at a distance L from A. Where is A? Maybe this is point A, right? At a distance L, right? Find the distance r from the axis to the point on the screen into which the charge strikes. What exactly he refers to? And one thing is very clear. Within one helix, it should strike the screen. That is the meaning of the question. So what is the time taken by the particle to reach T is equal to L by V cos phi. Suppose if it is a one pitch, I can simply say that the answer is very clear. What do you call, if it is one pitch exactly, what is one pitch distance? V cos alpha into time period, 2 pi m by pq. That is one pitch. I don't think that is what he is expecting. Is find the distance r from the x-axis. He is asking distance from the x-axis to a point on the screen into which the charge strikes. So what exactly he is asking? You need to work on that very carefully. Now, for this purpose, I will study much more claritatively. See, where is the direction of the magnetic field? I see, if I'm an observer standing over here, I'll see that the magnetic field lines are outward. I can say an outward magnetic field. And this is y-axis. This is z-axis. And you have this component V naught sine alpha like this. Outward means what is the plane of the circle? So plane of the circle is in YZ. Is it which side? Left side or right side circle? Mahant. ఎలా ఏది నెగిటివ్ జెడ్ యాక్సెస్ లెఫ్ట్ సైడా నెగిటివ్ రైట్ సైడ్ నెగిటివ్ జెడ్ అవుట్వర్డ్ ఫీల్డ్ సెంట్రల్ ఫింగర్ ఎలాంగ్ వై యాక్సెస్ తంబెడు చూపిస్తుంది ప్రతి తంబెడు చూపిస్తుందిరా ఇది లెఫ్టా So you have right, the thumb is directed rightwards. Right. So therefore, what happens is there lies your center. Now, for example, you take a point over here, which makes some angle theta. And instead of writing all the time, I'll write V perpendicular as V naught sine alpha. This is V perpendicular. Okay. And by the way, I know radius of the helix path. Radius of the helix path radius of helix path is equal to mv sin alpha by bq. Angle rotated during this time, theta is equal to omega t. Omega is bq by m times t. Okay. Now the question is, you are asking me a non-relativistic charge of, okay, point A, find the distance r from the x-axis to the point on the screen into which the particle strike. So you need to see that where exactly r is on the screen. You need to project r on my circle. Yes or no? Correct or not? Okay. Which means from the screen, I use a different line for this. Let this distance be r. Agreed? Hello, yeah. Agreed or not? This is r. This is r. This is r. Can you please help me in writing r properly? ఏంట్రా అంతే నేనే చెప్పుకుంటూ పోతున్నా. Lamis theorem. Small r by sin theta is equal to capital R by, see now this, if this is a theta, na, what is this going to be? 180 minus theta by 2. Correct kada? And pi minus theta by 2 or pi by 2 minus theta by 2. So capital R by sin pi by 2 minus theta by 2. So small r by 2 sin theta by 2 cos theta by 2 is equal to capital R cos theta by 2. So therefore, small r is 2 capital R sin theta by 2. Right. Sir, you have given too much of data. No, I haven't given too much of, this is the correct data. So R is 2 times M V perpendicular V sin phi by BQ. V sin alpha by BQ sin theta by 2. Theta by 2 means omega by 2 times T. T already I have written here. T already I have written. L by V cos alpha. That's all. This is your answer. In fact, see on the screen, suppose if it strikes at this point, this distance is what we will call as R. That's given in the question. I have no idea whether it strikes exactly at Y. ఇక్కడ స్ట్రైక్ అవుతుందని నేను చెప్పలేదుగా. It can strike anywhere. See, if I imagine on this screen, if I draw a circle like this, means this is the screen and this is a line parallel to Y axis. This is the circle. It can cut any point here. I repeat. It can touch any point here. In fact, they have given that distance as R. అంతేగాని don't imagine that it is a R refers to radius of the circle. Any doubts? You can ask me comfortably. Are we clear about this question? ఎవ్రీవన్ ఆదిత్య వచ్చావా? రైట్. ఆర్ వి క్లియర్ ఆన్ దిస్? జస్ట్ గివ్ మీ క్లారిటీ. ఏ డయాగ్రాము ఈ చివరి గీసిందా? అసలు మామూలుగా ఇక్కడి నుంచి చూసే అబ్జర్వర్కి అది ఎట్లా కనిపిస్తుంది? ఈ అబ్జర్వర్కి అది ఎట్లా కనిపిస్తుంది? ఇలా తిరుగుతూ ఉన్నట్టే కనిపిస్తుంది. అంతే ఫస్ట్ అడిగింది మిమ్మల్ని. ఇలా తిరుగుతూ తిరుగుతూ ముందరకు వస్తుంది అది యాక్చువల్గా. మీరు నుంచున్న చోట స్క్రీన్కి ఎక్కడ తగులుతుందో ఎలా చెప్తాం? ఆ డిస్టెన్స్ ఎల్లని బట్టి డిపెండ్ అయి ఉంటుంది. అంటే అది ఫర్ ఎగ్జాంపుల్ ఒక పిచ్ డిస్టెన్స్ ట్రావెల్ చేస్తుంటే ఇక్కడైతే అయి ఉండొచ్చు. పిచ్ డిస్టెన్స్ కన్నా తక్కువ ఉన్నా, పిచ్ డిస్టెన్స్ కన్నా ఎక్కువ ఉన్నా ఈ సర్కిల్లో ఏదో పాయింట్ దగ్గర టచ్ చేయొచ్చు. నేను అందుకే ఇక్కడ టచ్ చేసింది అనుకుంటున్నాను. నేను ఈ డిస్టెన్స్ ఆర్ అనుకున్నా, దాన్ని బట్టి చేశాను. క్లియర్గా అర్థమైంది ఇప్పుడైనా? నేను ఇంకా క్లారిటీగా ఎక్స్ప్రెషన్ రావాలి నీ దగ్గర నుంచి. ఈడే దాన్ని అది సైన్ రూల్ కదరా, ట్రయాంగిల్. అవునరా, ఇప్పుడు నీకు ఫీల్డ్ నువ్వు నుంచున్న చోట ఫీల్డ్ ఎలా ఉంది? నీ వైపు ఉంది, ఎలాంగ్ ఎక్స్ యాక్సెస్ ఉంది. ఇప్పుడు లెఫ్ట్ హ్యాండ్ రూల్ ప్రకారం ఇప్పుడు ఈ ఫింగర్ ఏమో నీ వైపు ఉంది. Central finger, makes a circle. Okay, upper half is the first quadrant, lower half. Right. Next question. See this. Everyone try to solve this. Take some time, no issues, but solve it. Actually, this is how the charge moves. In a region where both magnetic field and electric field are present, a positive charged particle is projected from origin at t is equal to 0 with a velocity v naught I cap plus j cap. It has two components. One component is along magnetic field. One component is perpendicular to the magnetic field. Here, fortunately, both are in the same direction. Both electric field and magnetic field are along the same direction. Try to remember yesterday's class. Notes తెమ్మని చెప్పా, ఎవరెవరు దగ్గర నోట్స్ చెప్పండి. ఒరే ఎవరు రా కలర్ జిరాక్స్ తీసుకో, నేనేమని చెప్పానా? మీ ఇంట్లో మళ్ళీ నన్ను తిడతారా? సంజన నోట్స్ తేలా, నిన్నేమో నిద్రపోయావు సగం క్లాసు. వీళ్ళ ఆడపిల్లలు ఒక్క నోట్స్ తేలా. అసలు మీకు క్లాసులు చెప్తాను దండగా నేను. నేను నోట్స్ ఇచ్చాను దీనికి. అరే అది ఏం కేసురా? మ్యూచువల్లీ పర్పెండిక్యులర్ కేసు. ఇది మ్యూచువల్లీ పర్పెండిక్యులర్ కాదు, అందుకే ఇది పక్కన పెట్టుకుంది నేను. ఈ కేసు మనం డిస్కస్ చేసేది. E bar, B bar parallel to each other and charge is projected along x-axis ఇక్కడ. కరెక్టేనా? చార్జ్ ఇస్ ప్రొజెక్టెడ్ అలాంగ్ x-axis. ఓకే, ఈ కేసులో ఏమవుతుంది? ఇది హెలిక్స్ పాత్రలోనే పోతుంది, ఇంక్రీజింగ్ పిచ్. What is the difference between this case and the case that which I am discussing right now? In this case, you see, you have electric field in this direction. You have electric field in this direction, magnetic field in this direction. And the velocity part has two components. One component in this direction, the another component in this direction. In the absence of the electric field, it would have gone through an helix like this. But there is electric field. What is the role of the electric field? Even now it is helix, but the pitch keeps reducing. But yesterday I taught you pitch will be increasing. Because in that direction, accelerating. Now this is decelerating because of the initial velocity. So therefore, from this it is very clear the retardation of the particle can be given as a retardation of the particle. The retardation of the particle can be given as retardation and rasa gavadu minus akkala. Q E naught by M. Right. What about I'll right. What about velocity? Velocity component along x, which is nothing but Vx is equal to V naught minus AXT. When will Vx becomes 0? Yet t is equal to some t naught, say Vx is 0. Then t naught is V naught by Ax. Till V naught by Ax, till mv naught by qe naught, the pitch keeps decreasing, and again the particle starts in the backward direction. Okay. Now the particle will exactly at x-axis during this time and is traveling in the y direction. How do I know this? Because now how do you know that it is exactly at the x-axis? Nothing is mentioned in the question. After some time, the charged particle is observed moving with velocity v naught j cap and tangential to positive x-axis. You will see that after some time, the charged particle is observed moving with velocity v naught j cap and tangential to positive x-axis. So what is happening now? That component tangential to x-axis. In this case, what is happening? Velocity is tangential. Okay. Right. You said tangential to x-axis kada. Right. ఇంకేముంది అక్కడ one more condition ఏంటి? The particle will exactly at x-axis traveling in y direction condition కావాలి మీకు. యాక్చువల్గా మీరు ఇది ఈ అబ్జర్వర్గా చూసుంటే మీకు అది ఎలా కనిపించేదంటే y Z ఒక కాంపోనెంట్ ఇలా ఉంది మీకు V0. మ్యాగ్నెటిక్ ఫీల్డ్ ఎట్టుకుంది మీ వైపు సేమ్ ఇందాక నేను చూపించిన కండిషన్. అంటే అప్పుడు ఇది ఎలా తిరుగుతుందని మీ ఉద్దేశం? పిచ్ ఇదే సర్కిల్ అయితే అదే. నువ్వేమని చెప్పావు? ద పార్టికల్ విల్ బి అట్ ఎక్స్ యాక్సిస్ ట్రావెలింగ్ ఇన్ వై డైరెక్షన్. ఆ ఇన్స్టెంట్ లో రైట్ ఆర్ నాట్? హలో, ప్యారలల్ టు వై యాక్సిస్ ఇలా తిరుగుతున్నప్పుడు ప్యారలల్ టు వై యాక్సిస్ టాంజెన్షియల్ టు ఎక్స్ యాక్సిస్ ఎప్పుడెప్పుడు అవుతుంది? ఎవ్రీ వన్ టైం పీరియడ్కి అవుతుంది అది. ఎవ్రీ వన్ టైం పీరియడ్కి అవుతుంది అదే. వాట్ ఈస్ టైం పీరియడ్ హియర్? 2 pi m by pq. So what is T naught here? T naught here is mv naught by eq naught. ఓకేనా? సో ఇప్పుడు ఈ రెండిటి నుంచి ఈ రెండు ఈ వన్ టైం పీరియడ్, సరే, ఇన్ దిస్ క్వశ్చన్ యూ మెన్షన్ with this data I can say this and this one is the same. See, it is of different possibilities. One time period or even n time period is also possible. It will come to x-axis in the same way with its velocity parallel to y-axis. So therefore, what I will try is mv naught by eq naught is n times 2 pi m by bq naught. Cancel. So E is mm cancel. BV naught by 2 pi m. So E by B naught is E by B otherwise is V naught by 2 pi m. Please ask me if you have doubt. I am repeating, he himself uttered an information. At an instant when the velocity becomes 0, x component of velocity becomes 0, it is tangential to x-axis with its velocity directed along y-axis, which means you need to have a situation like this. That happens either after one circle or after n circles. Any doubts? Pakka? Sure? Right. So move on to this question. A positively charged particle with specific charge sigma starts moving from the origin with a velocity directed along positive x direction. Okay, that is the first part of the data. The entire space has a uniform electric field as well as magnetic field be directed along positive y direction. Both are directed along positive direction. This is the case which we have discussed here. Right. Remember, both are directed along y-axis, but the particle starts moving from the origin with a velocity u directed along positive x direction. Now we will take this as this is the particle y-axis, x-axis, both E, B are along y-axis and you have projected that along x-axis. Right. So if you are an observer from the top, you will observe two things. One is x-axis, z-axis. You projected it like this. Now here in this diagram, central finger is along the x-axis, pointing finger upwards, thumb is downwards. Yes or no? Now what happens? దిస్ ఇప్పుడు ప్రాబ్లం ఏమవుతుందని నేను చెప్తాను, ఇంత చెప్తున్నా. మీరు చాలా సినిమా యాక్టర్ యాక్షన్ చేసినట్టు చేస్తారు. వారం అయిపోయి సాటర్డే రోజుకి వచ్చేటప్పటికి సార్ డైరెక్షన్స్ కన్ఫ్యూజింగ్ ఉన్నాయి సార్, ఏం చేయమంటారు సార్ అంట. లాక్ కొట్టాలనిపిస్తుంది అప్పుడు. నేను ఇప్పుడు చెప్తున్నప్పుడు దున్నపోతల్లా వినరు మీరు. మీకు నిద్రలు వస్తాయి, మీరు మూడ్లో ఉండరు, మీకు మళ్ళా మీరు రెడీ అంటే నేను పాఠం చెప్తాను అన్నట్టుగా ఉండాలి మీకు. ఈ ఆన్లైన్ రికార్డ్ అవుతుంది కాబట్టి నేను చాలా రిస్ట్రిక్టెడ్గా చెప్పుకోవాల్సి వస్తుంది. రైట్, మళ్ళీ చూసుకోండి డైరెక్షన్. ఏసీ ఆపేయండి, అసలు చెమట పోతుంటేనే ప్రశాంతంగా ఉంటుంది మీరు. సెంట్రల్ ఫింగర్ అలాంగ్ ఎక్స్ యాక్సిస్, ఫోర్ ఫింగర్ అలాంగ్ y axis, thumb is now along z axis, left hand ఆటోమేటిక్గా ఏమవుతుంది, ఇలా జరుగుతుంది. అది that is how your circle is. Any doubts? Now the question is, and that circle keeps moving up with an increasing pitch. Find the angle that the velocity of the particle makes with the y-axis at the instant it crosses y-axis for the nth time. No issues. At the instant it crosses, antega, very simple. At that instant you will have two components. One, the first of all, nth time kada. Time enta cheppandi. Time is 2 pi m by bq. 2 pi m by bq. And nth time. So therefore t is 2 pi nm by pq. Right. So therefore at that instant, what is Vy component? Vy component is QE by m into t. QE by m into 2 pi n m by bq. 2 pi ne by b. That is Vy. Any doubt? No, already you know Vx. What is Vx? The speed with which you are projected. It won't change anyway. U. What do you want? What do you want? Direction with what? I mentioned yesterday. I have Vy direction. I have Vx direction. So tan alpha is Vy by Vx, which is 2 pi ne by bu. So what is this angle? This is the angle made with xz plane actually. XZ plane. This is the angle made with XZ plane. And no sir, what is the angle with the y-axis? In that case, flip curve. So alpha is with the XZ plane. 90 minus alpha కావాలి మీకు. So tan 90 minus alpha cot alpha bu by 2 pi ne. This is angle with y axis. I'm asking again, do you have any doubt? Pakka? Sure? Right. Any doubt? Next. Next question. Please go through the question. I'm facing problem. Stylus ఎందుకో పనిచేయటం లేదు. A positively charged particle having charge Q is accelerated by a potential difference V. The particle moves along the x-axis, enters a region where an electric field E exists. The direction of the electric field is along the positive y-axis. The electric field exists in the region bounded by the lines 0 to A. X is equal to 0 to A. తర్వాత magnetic field కంట్రోల్ అవుతుంది. No issues. We will try to understand the possible data given in this question. Right. మనం ఒక పని చేద్దాం, రీజియన్స్ గా డివైడ్ చేద్దాం. ఆ రీజియన్ అంతా ఎలక్ట్రిక్ ఫీల్డ్ రీజియన్. You know, when a charge enters, it follows a track like this. Yes or no? What is the nature of this path? What is the nature of this path? Sanjana, what is the nature of the path? Aditya, what is the nature of the path? Why parabolic? Very good. Yesterday I taught this. సంజన నిద్రపోతున్నావు నువ్వు. నిన్న చెప్పాను నేను, ఎలక్ట్రిక్ ఫీల్డ్ అయితే ఏం పాత్ అవుతుంది, మ్యాగ్నెటిక్ ఫీల్డ్ అయితే ఏం పాత్ అవుతుంది, నిన్ననే చెప్పాను నేను. ఇట్స్ ఎ పారాబోలిక్ పాత్. అండ్ బై ది వే, that is the velocity direction. Now with this velocity, it is entering into which region? Magnetic field. Now this will follow which path? By the way, hello. Which path? Helical path actually. Why? Because the velocity vector and B is in the same plane. and it makes some angle with the B bar. It will follow a helical path, right? First, at which point does the particle meet the line? No, beyond first, along the, what are the question? Find at which point does the particle meet the line x is equal to a? No issues. See, already you projected with, I think you projected with some velocity, right? You have accelerated and projected, means is this a problem in the stylus or with the, if I find the same problem, I need to switch off to this system. Suppose in case if I am unable to write in the tab, I'll shift over. It might take some time, 2-3 minutes. Let me try. Now in this, I can clearly mention, uh, Q into, it's a problem with the pencil only. Right. So in this particular case, first of all, by the time when it is entering here, what is its velocity? Let that be u. How do I know u? How do I know u? So q into v is equal to half m of m u square. So from this, I can say that I know u at least. Root 2 qv by right. First part is done. Not the first part, actually. No, you said it is at a distance A. So see, the component along x-axis remains the same because the electric field is in which direction? The electric field is in which direction? The electric field is in y direction. So therefore, what I can say confidently is the time taken. The time taken is clearly T is equal to A by U simply. Now this is Y1, for example. So what is Y1? Y1 is half QE by M T square, A square by U square. So QE A square by 2M U square. That is Y1. First point, at which point does the particle meet line x is equal to A? I have given. Next, the pitch of the helix formed after the particle enters the region x greater than A. Now, for example, what angle that you are entering, that also I want. So tan theta is Vy component by Vx. Correct hai? So this is nothing but Vy means QE by M T. Hello, AT by Vx U. And I know what is T, by the way. T is A by U. Andega? So therefore, it is like QEA by MU square. Why I require theta? Because in this, if this is the direction of B, and if this is the direction of the resultant velocity, that instant. Remember, we know this is theta. Okay, we know that is theta. That's what I have derived, right? And this is V. And this is some phi. Of course, phi is 90 minus theta. Yeah, express. What is the formula for pitch? Pitch require first time period. 2 pi m pi pq. And what is the expression for pitch? అరే ఇక్కడ రా ఇక్కడ v cos theta వేస్తా మారింది v cos phi times time period. What is v cos phi? V sin theta. Into time period. మీకు ఇంకో విషయం చెప్పనా, జాగ్రత్తగా వినండి. ఇది v కదా, ఇది theta కదా, ఓకేనా? v cos theta అంటే ఏదో కాదు, యూనే. v cos theta అంటే యూనే. అలానే v sin theta, ఇక్కడ v cos phi, of course. v cos phi అంటే ఏంటో తెలుసా? vy కాంపోనెంట్. అదేంటి vy కాంపోనెంట్ ఏంటి? ఇక్కడ యాక్చువల్గా vy కాంపోనెంట్ QEA by MU. Instead of writing V sin theta, this is V sin theta. Instead of writing V sin theta, you can make it like this. So therefore, finally, you can have a situation like this. So finally, what you have, tell me? QEA by MU times time period. What is time period? Entara? 2 pi m by pq. క్లియరా? ఇప్పుడు ఇందాక రాస్తున్న దానికి దీనికి ఏమన్నా రైటింగ్లో కొంచెం తేడా ఉందా? బాగానే ఉందా? మోర్ ఆర్ లెస్ బాగానే ఉందా? రైట్. నాకు చికాగ్గా ఉంటుంది ఇది. కంట్రోల్స్ పనిచేయవి ఇంకా. రైట్. దీంతో పని లేదు కదా మనకి, ఇది తీసేద్దాం. రైట్. ఎక్కడున్నాం మనం? ఇక్కడున్నాం. ఎనీ డౌట్స్? ఎక్సలెంట్ క్వశ్చన్ ఇది, ట్రై చేయండి. కొంచెం ఇంకొంచెం ఫాంట్ సైజ్ పెరిగింది ఇప్పుడు. Make sure you work on this. Very good question actually. Very good question, Ravi. Particle of charge q and mass m is projected from the origin with a velocity v naught I cap. Find the maximum positive x coordinate of the particle during its motion. You will definitely get this question anytime, either in VAT or some other form of examination. That is supposed to be your answer. Right. Now let us work on this particular question. What exactly is happening? Let me try to understand. Why they uttered a term called maximum positive x coordinate. Now I am assuming that this is some y coordinate. This is some y coordinate. y-axis otherwise. And this is x-axis. You are in a region of inward magnetic field. అందుకని అంతా రైట్లా నేను inward magnetic field that changes with x. ఏదైతే నీకు ఎందుకే నువ్వు ఎటు ప్రొజెక్ట్ చేస్తావు ఛార్జ్ని ఎటు ప్రొజెక్ట్ చేస్తావు నువ్వు you have projected the charge like this and that makes that too with the speed v naught. అరే ఒకవేళ అది యూనిఫార్మ్ మ్యాగ్నెటిక్ ఫీల్డ్ అయి ఉంటే ఏమయ్యేది ఫ్లెమింగ్స్ లెఫ్ట్ హ్యాండ్ రూల్ పాయింట్ సర్క్యులర్ లేరా పాయింటింగ్ ఫింగర్ ఇన్ టు ది ప్లేన్ ఆఫ్ ద ఐప్యాడ్ కాదు ఇప్పుడు స్క్రీన్ రైట్ and central finger along x-axis, thumb is along y-axis. It would have done a circular path with the circle. X-axis has the tangent of the circle, and the center would have laid on y-axis actually. But the problem here is, since B is changing, the nature is different at different points. Like for example, we will consider that the nature is something like this for my convenience. For my convenience, I'm assuming something like this. At this point of time, but one thing is observable. What is that? Its speed remains the same. Palvita, why? Its speed remains the same. Why? Aditya Jappu, why? ఎందుకురా దేర్ ఇస్ నో అరే నువ్వు ఎప్పుడు డైరెక్ట్గా ఆన్సర్ చెప్పవురా కదరా నువ్వు ఏమని చెప్పాలి ఇప్పుడు మ్యాగ్నెటిక్ ఫీల్డ్ డస్ నో వర్క్ అని చెప్పాలి నీ ఉద్దేశం అదే యాక్చువల్గా అది చెప్పకుండా ఇంకోటి చెప్తున్నా ఐడెంటిఫై ద కరెక్ట్ ఆప్షన్స్ అవుట్ ఆఫ్ ద ఫాలోయింగ్ అని ఇచ్చాడు మల్టీ కరెక్ట్ ఆన్సరు ఏబిసిడీలలో బీసీ నువ్వు ఏం మార్క్ చేస్తున్నావు అంటే ఏడి పెట్టి ఇవి కాదని చెప్తామని నీ ఉద్దేశం అడిగే నీకు మార్పు ఏం వస్తాయి దానిలో -2 వస్తాయి రెస్ట్ సో నౌ ద క్వశ్చన్ ఈస్ this makes some angle theta, for example. And by the way, the force, electric field force, magnetic force is at right angles to this. Exactly, yes or no? There is exactly at right angles to this. Okay, fine. Magnetic force, I have identified. What is AY according to me? What is AY according to me? What is AY according to me? కాదరా ఏవై అంటే ఇక్కడ ఎఫ్బి కదా ఇప్పుడు ఇది తీటా ఇది 90 మైనస్ తీటా ఇప్పుడు ఏవై అంటే ఏం రాస్తారు మీరు వెరీ గుడ్ ఎఫ్పి ఈజ్ అ ఫోర్స్ బై మాస్ ఈజ్ అ టోటల్ యాక్సలరేషన్ సైన్ తీటానా కాస్ తీటానా ఒరే నేను తంతారైరే ఎలాంగ్ ఎక్స్ యాక్సిస్ కాదు ఏ వై అడుగుతున్నా నేను అది సైన్ 90 మైనస్ తీటా అవుతుంది ఆపోజిట్ సైడ్ దానికి కాస్ తీటా అవుతుంది ఈక్వేషన్ 1 రైట్ of course at any point fp is given by bqv bqv is always V is fixed. So it is minus Bx Q V naught. This is equation 1. Right. AY is this. Now what is AY? You write properly again. B naught X Q V naught by M cos theta. Right. By the way, if you ask me what is AY, I have one more answer. dvy by dt is B naught X Q V naught M cos theta. That is dvy. So I got a very clear picture about dvy. If you permit me, I will write another way also. This fraction I can write in another way. dvy by dx by dt is B naught X Q V naught cos theta by M. ఈ ఇంట్రాను మొత్తం అంతా మార్చిపారేస్తున్నావు, నాకు డౌట్గా ఉంది అని మీరు నన్ను అడగచ్చు. V naught cos theta అంటే ఏంటి? V naught cos theta అంటే Vx అంటే ఏంటి? dx by dt. ఈకేట్ చూస్తావు వేసేయి. రైట్ రైట్ ఓకేనా? ఇప్పుడు ఫైనల్లీ వాట్ ఐ గాట్ ఈస్ dvy is B naught Q by mx dx ఇంటిగ్రేషన్. ఇక్కడ సెంటిమెంట్స్ మారుతాయి. x is equal to 0 దగ్గర vy 0. x max దగ్గర ఏమవుతుంది? కంప్లీట్ y డైరెక్షన్లో ఉంటుంది. బాయ్స్ అండ్ గర్ల్స్ అంతే కదరా. ఎక్స్ మ్యాక్స్ అంటే అర్థం ఏంటి? ఇంకా కాంపోనెంట్ లేదని అక్కడ ఉన్న స్పీడ్ అంతా ఏ డైరెక్షన్లో ఉంది? వై డైరెక్షన్. దిస్ విల్ నౌ ఎంప్లై వి నాట్ మైనస్ 0 ఈజ్ pq by 2m x maximum square. So therefore x maximum is 2m v naught by pq. సూపర్. చూసుకోండి ఒకసారి అంతా. ఎనీ డౌట్? If you have any doubt, ask me right now. Boys and girls. పక్కా? బాయ్స్ చేస్తాను. ఇంకా కొన్ని మోడల్స్ ఉన్నాయి, చేస్తాను. రైట్. ఐ విల్ స్టార్ట్ అనదర్ థియరీ రైట్ నౌ. So some basic theory I have given on this, so I will start another theory. What is this theory? Magnetic force on a current element. Now imagine that you have a very tiny small current carrying element. Now according to me, what is current? Sanjana, I is equal to NEAVD. Yes or no? Now you are taking a small portion here. You are taking a very small portion here. In this small portion, now this you can write it as, this part you can write it as dq by dt is NEAVD. So on integration on both the sides, this can be written as NEADL. NEADL. Sanjana, clear? Right. ఇది వేవ్స్ లో చాలా ఇంపార్టెంట్ కాన్సెప్ట్. సంజన కరెక్టే కదా? కరెక్టేనా? నా పొంద వేవ్స్ లో ఇంపార్టెంట్ కాన్సెప్ట్ ఏంటిది? కరెంట్ ఎలక్ట్రిసిటీలో చదువుకున్నా. చూసా నువ్వు యాక్టివ్గా లేవు. నా డిఎఫ్ బార్, అవునా? ఇది ఒక చార్జ్ ఒప్పుకున్నాగా ఇప్పుడు. And this is all a charge, and the charge is moving with VD velocity. Then what you will write? DF bar is equal to Q V bar cross B bar. Q means NEA DL VD bar cross B bar. And totally the entire thing, just now I have mentioned, it is DL bar. DL bar. I is NEAVD, and by the way, DL, అదే కదా నేను మోడిఫై చేసిన పిక్చర్ మీకు అర్థమైందా? You can write it as IDL bar cross B bar. If you still have any confusion, I can further modify it like this. DF bar is NEA V bar times DL into B bar. Now you use NEAVD plus I. So you will get I DL bar cross P bar. Remember, you should identify current element. Current element definition is, it is a small element and whose vector direction is along the direction of the current at that point. You remember, current element DL bar direction is along current at that point. And don't forget this. Now you can apply Fleming's left hand rule for this also. How? Again, stretch your left hand 3 fingers. Stretch your left hand 3 fingers such that the pointing finger shows B bar, central finger shows the current direction, and a thumb represent shows force acting on this element. Imagine the 3 fingers are stretched mutually perpendicular to each other. 4 finger shows the direction of B. Central finger shows the direction of current. Thumb represents the direction of force. Okay? This is how. For example, if you have a straight current carrying conductor like this, and this is B, and this is the inward direction is B. Now you again stretch the left hand 3 fingers like this. and you stretch your left hand 3 fingers like this, and in this left hand 3 fingers, try to please see that the pointing finger is into the plane of the board and central finger is upwards. So left hand side you will have a B. A B. So therefore, very clearly, FB is given as I L bar cross B bar. Simply, you can write this as FB is B I L. Now, I have an arrangement like this. It's a non-uniform field. It's a non-uniform field. And you place this loop in this field. Now current is flowing. You can see every element here will experience a magnetic force perpendicular to this, perpendicular to this, perpendicular to this, likewise. So like you have seen the same situation in surface tension. Do you remember? On a soap film, you place a loop and you have punctured the inside part. What happens? The loop will now take the shape of a circle. Same happens here. It will take the shape of a circle. Net force is zero undoubtedly. But because of these perpendicular forces, a tension is developed in the string. How to find that tension? Simple. Now you see there is a tension force here, there is a tension force here, and there is magnetic force here. Now you take a small element over here. You take a small element like this. This is the small element. And on this small element, you have these are two tension forces. This is a very small angle d theta. And this is your FB. This is tension, this is tension. You know dF is 2t sine d theta by 2. I BDL is t d theta. So I into R d theta B is t d theta. So tension is BIR. Very important relation, because you will get formulas on this at a later stage. Even if it is a non-uniform magnetic field, but linearly varying. Linearly varying, and in the Kalaka B naught X, and you place this loop. In that case, also net force is zero. So, any doubt in this, please ask me. I have just introduced the force on a current element. Now, because of this force, different issues will trigger. What are they? Now, because of this, a current carrying conductor will also act as a magnetic dipole. You will see some proof related to this in next week, but that part is involved here only. A current carrying loop will behave like a magnetic dipole. For example, here you are seeing a loop in this mode. Okay, in this mode, the current is flowing in anti-clockwise sense. If we are seeing the loop at this stage, you are seeing the actual north pole of this loop. Ela ante use a right hand grip rule. Right hand grip rule. According to this rule, if we are holding a current, if we are uh, turning 4 fingers along the direction of current, then thumb represents north pole. For example, in this case, if I am turning the four fingers in this particular case, I'm speaking about, in this case, thumb is pointing towards me. So in fact, I'm seeing a north pole actually. If the thumb is into the plane, I won't see north pole. Outside, other side person see north pole. So I am seeing the tail of north pole. So which is south pole. So whether you see the loop in this form or this form or this form, in any of these cases, first point is current is anti-clockwise. Now this behaves like a loop. So it behaves like a magnetic dipole, and the magnetic moment is given as I into A. Current times the area of cross section. This is per loop. If there are n turns, in that case, if there are n turns, then in that case, the magnetic moment is given as M is equal to NIA. Similarly, I can express the same thing. Similarly, I can express the same thing here. Opposite sense, it is south pole. Use the right hand grip rule only. Now you will turn right hand, four fingers such that the thumb is into the plane of the paper. So you are seeing the tail of the thumb, south pole. Okay. Next, one more important point. Suppose you see in XZ plane, you have this circle. You can see this circle. This is a loop. And this is carrying current. What I have done, I have turned my right hand fingers, placing my thumb parallel to Y axis. Now, along Y axis, I have magnetic moment. Okay, got the point? But you see, the nature of the loop here is slightly different. The nature of the loop here is slightly different. Why? Now, it is in 3D plane. Why? Now you can see some portion is in XY plane, some portion is in YZ plane, and some portion is in XZ plane, or whatever it is. It will have three components, and each is a quarter circle. So area is pi r square by 4, and it is the same current that pass through all. So therefore, in this case, it is the same current that passes through all. So therefore, what I can write the magnetic moment is, see, you have one vector perpendicular to, if I turn my right hand in XY plane, thumb is along Z. If I turn my four fingers of right hand in YZ plane, thumb is along X. If I turn my right hand four fingers in XZ plane, thumb is along Y. So this indicates that magnetic moment is along mr square by 4 I common, I cap plus j cap plus k cap direction. In a three-dimensional view, this is how you will manage. I'm just giving you the basics. After doing some numericals, you will get to have an idea about how to estimate that. Are we clear till this point now? The magnetic dipole in uniform magnetic field. Magnetic dipole in uniform magnetic field. You already have done this in electrostatics. Electric dipole in uniform electric field. Same thing. Only thing the difference is the direction of the dipole is from south to north. Dipole moment m bar is directed from south to north. Whereas dipole moment in case of electricity, P bar is from negative charge to positive charge. That is how it is analogous. So there you have written P bar dot E bar. Here you will write M bar dot P bar. Whereas when you place this dipole, it will experience a torque given by tau is equal to M bar cross P bar. Magnitude is MB sin theta. There also in electrostatic, in electric dipole case, the potential energy is minus P bar dot E bar. Here it is minus M bar dot B bar, and it is minus MB cos theta. There also you have studied. If the electric field and dipole are along the same direction, that is called stable equilibrium state. Here also, magnetic field and magnetic dipole along same direction means it is stable equilibrium state. You disturb from here, it will do small oscillations. If the oscillations are very small, it will execute SHM also. So what is the restoring torque? Minus MB sine theta. So I alpha is minus MB sine theta. I alpha is, and the angle is small, minus MB theta. Alpha is minus MB by I theta. That is the condition of angular SHM. So in the place of omega, you have root MB by I. In the place of time period, you have 2 pi root I by MB. So if a magnetic dipole is placed in stable equilibrium position and slightly disturbed, it will execute SHM. Remember, the field must be uniform in that case. In a non-uniform, you cannot express this. Till this point, any student having doubt? Pakka. Next. Okay, now how you will get dipole? That is the first question. Okay, you have current carrying loop, fine. Is this the only source? No. A moving charge, a circulating charge is also equivalent to a magnetic dipole. That we will work on. How? For example, you have a charge Q. You can see the charge Q here. Now this is moving in a circular path like this. Like this. Moving along a circular path like this. This is equivalent to a dipole, actually. This is equivalent to a dipole. Gaurav. So how? Very simple. It is a positive charge. Since it is a positive charge, this is how equivalent to a current loop. And then the positive charge was a current loop. Then curl the four fingers of right hand in that direction. Thumb represents magnetic moment. Now, for example, how current is defined in this case? Current is charge by time period. Current and charge by time. Here Q by 2 pi omega. So magnetic moment is IA. Q omega by 2 pi times pi r square. So finally it is a Q omega r square by 2 magnetic moment. By the way, what is angular momentum? Because it is a point mass. MVR, mr square omega. You see M by L is Q by M. Remember, this is a constant for any distribution. Linear distributions. And that constant of proportionality is called gyrometric ratio. Gyrometric ratio. Any doubts? Boys and girls? So I have just introduced. For example, what if it is a charged thin rod? What if it is a charged thin rod rotating like this? Very simple. I will select only one charge moving like this. So what is the magnetic moment contribution of one such charge? You have the formula Q omega r square by 2. That is what I am writing. This is a Q. Sir, why you have written 2 times? One element over here. A similar element is also here. So 2 times lambda dx omega. In the place of r, I have written x square by 2. Do the integration part. Limits 0 to L by 2. Because this is x is equal to 0, this is x is equal to L by 2. So I have done this lambda omega x cube by 3. L cube by 3. But actually L cube means L cube by 2 cube actually. So you have 8 term. So Q omega L square by 3 into 8. Keep this aside. What is angular momentum? I omega. I means ml square by 12 omega. So I have done m by L. I got again the same relation. Charge by 2m. Only for linear distributions only you can apply. Non-linear distribution, you won't get this relation. Only for uniform distributions, you will get this relation. Likewise, charged thin, uniformly charged insulating shell. Because entire charge is break anything make. Then, what is the time now? Okay, we have time. Right. This I will discuss tomorrow otherwise.